So in Module 6, we're going to be talking about work and energy. And so this is a pretty big topic that has a lot of transfer into our everyday lives, into other areas as well. So one of the things that pop up in work and energy is that work is kind of similar to how acceleration was, where what we would talk about as work in our everyday lives, in our just normal conversations, doesn't necessarily match up with the physics definition of work. So remember, with acceleration, you can have something slow down and it be accelerating. But in our everyday language, we never talk like that. We never say that, when we see a car slowing down, we don't say that it's accelerating. But in physics, we do. So the same sort of thing is going to happen with work. And then the next slide, I'm going to have an example that would make it clear where our everyday definition of work fails. So in physics, when we talk about work is the energy transfer between surroundings and a system by forces. So a system could be, in the previous modules, we've dealt with blocks as systems. It's whatever object of interest or objects of interest that you are looking at. That's your system. Everything else is your surroundings. So the system in this bottom right picture of the bungee jumper, the system would be the person and the bungee, and the surroundings would be everything else. So much like with forces, when we had to choose what our system was to draw a free body diagram, with work and energy, we are going to have to define what our system is. Everything else becomes our surroundings at that point. So mathematically, what is work? Well, work is the force, the magnitude of the force, times the magnitude of displacement, times the cosine of the angle between them. So if your force is in this direction and your displacement is in this direction, the angle between them is 0. But say if your displacement is in this direction, say we have a block and we're pushing up on it like that, our force is in that direction, then the angle between those two is this angle right here, theta. And so basically what you're doing is you're taking the component of the force that is parallel to the displacement. So by taking cosine of the angle between them, you're making sure that the component of force is in the direction of displacement. So what are some of these pictures that I have up here? How do they relate to work and energy? Well, one of the big items in energy is this idea of spring energy. A spring stores energy. When you compress it down, when you push down on it, you're putting energy into the spring. That energy is being stored within that spring. And then when you let go, it starts to move. And so that is transferring energy out of the spring. So every time you click on a pen or a mechanical pencil, you're applying a force to that spring. You're adding energy into the spring potential energy. So you're storing energy within that spring, where that energy later gets transferred to something else. What about down here with moving? Well, with moving, we have to do work to move our objects. We're applying a force up the ramp to get our objects up into the vehicle. And so we have to do that force over some distance. And what do we accomplish by doing that? Well, we get our objects from some starting point up to a finish point. So we have to give energy, or we have to transfer energy into our object to change its position. So that's just another example of an everyday life. Down here with bungee jumping. So this bungee actually acts as a spring. So these two are actually the same thing when it comes to physics. The bungee acts as a spring. And so what happens? You fall from, you're in free fall. You're going down towards that lake. You're gaining all this speed because you're losing height above the lake. So you're taking your gravitational energy and you're transferring it into kinetic energy, which is this movement energy. So you're increasing your speed. And what do? Well, you hope there's something to stop your speed because, you don't want to end up in the lake, right? I mean, that wouldn't feel too good. So you must be transferring energy into something else. Something must be taking away that energy that you have, that kinetic energy that you have as you're moving through the air. And what is taking that energy away? Well, that's being transferred into spring potential energy, which is the bungee cord. And of course, too much energy, or if there's a great enough force, causes the bungee to break. And that's when you see those videos that are kind of scary when the bungee breaks and you just keep falling. So you have nothing to take away your kinetic energy. You have nothing to transfer your kinetic energy into once that bungee breaks. And then for a biology reference, again, we're gonna draw off of this idea of springs. Springs are everywhere in nature. And so springs are again seen in biology with this idea with collagen. So collagen is a type of protein. And so what it does is it forms itself into these fibers. And these can be represented as a spring. So what they can do is you can compress them or you can stretch them. And they behave exactly like a spring would do when you stretch or compress a spring. And so we have an example here of what we experience in our everyday lives and whether or not it's considered work in the physics sense. So in Oktoberfest out in Germany and just all over the world now, there's this Stein holding contest that they do. And so you have to hold this mug of beer with your arms completely stretched out. Whoever holds it for the longest wins. And so this applies to anything that you hold out and you keep stationary. Is work being done when you hold something out and you're not moving it? So let's look at the math. So take a second and answer whether or not you think work is being done in your everyday sense of what you would call work. And so let's take a look at the math of it. So we have the force times the displacement times the cosine of the angle between them. So what are the forces acting on the beer? Well, we've got a weight force downwards. It's not moving, so we must have a normal force upwards counteracting it, and that normal force is being applied by the hand. So are we doing work with the force of our hand? So F hand, what is the displacement of the mug? Well, it's not moving anywhere, so the displacement must be 0. Cosine of the angle between them doesn't matter because this whole thing is 0. So for an object that's just being held stationary, not moving up or down, the work done is 0. Does that match up with what we would call work in our everyday lives? Well, I would feel tired doing this, right? So obviously I would say, man, I must have been doing work on this, right? And so this is where the physics definition differs from what we would call work in our everyday lives. So what we're actually feeling is just the effort that our body is undergoing to hold up this beer. So we're not doing work on the beer. All of this effort is happening internally to us. So there's no work being done on the beer. It's just what we're feeling because our muscles are having to fire. And then finally, we've got our learning objectives for this module. Some of the big ones, we're going to be looking at spring force and spring potential energy. Like I said, springs are everywhere in nature. There are so many biological things that can be represented as a spring in a way, or a spring force in a way. So it has a lot of applications in biology, in muscles and muscle movements. And then we're going to be looking at, again, free body diagrams that's popping up, and that will remain within the rest of the semester. We're going to be doing these things called work diagrams. And so this is where we're going to be using forces to help us figure out, is work being done? Is it negative? Is it positive? What type of work is it? And then we're going to be talking about gravitational potential energy. Much like in the bungee cord or the bungee jumping example, where when you move your height, you're changing your gravitational potential energy. So take a look at these, keep these in mind as you're going through the module, and kind of check them off as you see them pop up.